Hey everyone, and welcome back for another deep dive. Today, we're going deep on a topic that's super important for anyone who works with cranes. You know, wire rope safety.
Definitely important.
Yeah, whether you're already a crane operator or you want to be one, or maybe you're in charge of safety on job sites, this information from Safety One Source is for you.
Absolutely.
We're going to be looking at OSHA's guidelines, specifically Section 1926.1414, which covers like everything about wire rope.
Yeah, that's the one.
From picking the right rope to making sure it's installed correctly.
It really does. It's pretty comprehensive.
So that's what we're diving into today.
You know, wire rope is kind of the unsung hero in crane operations. When you really think about it, it's holding tons and tons of weight.
Yeah, it is.
And if it fails, well, it could be a disaster.
Exactly.
And that's exactly why OSHA put these regulations in place to make sure that every lift is as safe as possible.
Right, so 1926.1414 is like our wire rope Bible.
You could say that.
It seems pretty technical, though. Where do we even start?
Well, think of it like this. OSHA wants to make sure that any wire rope used on a crane is strong enough for the job, it's compatible with the crane itself, and it's properly installed.
Right, because a broken cable hundreds of feet in the air is not something anyone wants to see.
It would be bad.
How do we make sure we're picking the right rope in the first place?
Yeah, that's a good question.
It's not as simple as just grabbing the thickest one and calling it a day, right?
No. Picking a wire rope isn't a one-size-fits-all situation. First, you got to check the manufacturer's recommendations.
Okay.
They've done all the testing and engineering to figure out exactly what kind of rope works best with their equipment.
But wouldn't a thicker rope always be safer?
Well, not necessarily.
Just more strength has to be better.
Not always.
Right.
Think of it like putting, monster truck tires on a compact car.
Oh, okay.
It wouldn't handle properly. In the same way, if you use a rope that's too thick for your crane, you could have problems.
I see.
It could not spool onto the drum, right? Or cause too much friction.
Yeah.
But if you use a rope that's too thin, it could slip.
And that's obviously a huge safety issue.
That's a major hazard.
Okay, so it's all about finding that right fit for the crane on the job.
Absolutely the right rope for the job.
But how do we know if the rope is actually strong enough for the load?
Another great question. OSHA has two ways to make sure you're roped up to the task.
Okay.
One way is to follow these guidelines from the ASME B30.5 standard. It's basically the engineering rule book for cranes and lifting equipment.
Gotcha.
It's full of formulas and calculations to figure out the minimum braking strength.
So option one, the rule book?
Right.
What's the other way?
Option two is to make sure the rope's braking strength is at least 5 times greater than the load you're lifting.
Wow, okay.
This safety factor of 5 is super important because it accounts for things like wear and tear and other things that can weaken the rope over time.
5 times stronger than the load, that's a pretty big safety margin.
It is.
What if the rope is brand new, though? Shouldn't it be able to handle even more weight?
Well, theoretically, yes.
Yeah.
But remember, safety is paramount here.
True.
OSHA isn't taking any chances.
I see. So the 5 times rule is there to make sure even with wear and tear,
right, exactly,
it's still strong enough.
Yeah, still same.
Okay, that makes sense.
Good.
So we've talked about picking the right rope,
right,
the right thickness, the right strength.
Yeah.
What's next?
Well, there's another important thing, especially when we're talking about raising and lowering the boom of the crane, and that's where rotation-resistant ropes come in.
I'm not sure I'm familiar with that term. What makes those ropes different?
So imagine you're lifting a massive steel beam, like for a skyscraper.
Okay, yeah.
If the wire rope starts to twist, that beam could start spinning.
Oh, wow.
Uncontrollably. And that's not good.
Definitely not a good situation.
Rotation-resistant ropes are specially designed to prevent that twisting.
I see.
Keep that load stable and safe.
So how do they actually prevent twisting?
It's all in how the rope is made.
Okay.
There are actually 3 types. Type I, Type 2, and Type 3, each with different levels of resistance.
Okay.
Type I is like the heavy-duty champ with a complex construction of at least 15 outer strands woven in multiple layers.
Wow.
It's, super strong, twist-proof, designed for those really heavy lifts.
So Type I is for the big jobs.
Yeah.
What about Type 2 and Type 3?
Type 2 has at least 10 outer strands, and it's a bit more flexible.
Okay.
While Type 3 has a simpler construction with no more than 9 outer strands. They offer, varying levels of resistance, making them suitable for different things.
So like choosing the right tool for the job.
Exactly.
Depending on how much resistance you need.
You got it.
And that's where OSHA comes in again with those specific guidelines.
That's right.
On when to use each type.
Right.
So they're kind of like the referee, making sure everyone's playing by the rules.
You got it.
And using the right rope for the situation.
Exactly.
It's all starting to come together now.
Good.
But you mentioned these rotation-resistant ropes are often used for raising and lowering the boom. Is there a specific term for that?
Yes, it's called boom hoist reeving.
Okay.
Think of it as the system that controls your arm. Like the wire rope is the muscle.
Okay.
And boom hoist reeving is how that muscle works to lift and lower the boom.
Okay, I'm picturing it now.
Good.
So what does OSHA have to say about this whole boom hoist reeving system?
Well, for starters, they're very specific about what kind of ropes can be used.
Uh-huh.
Fiber core ropes, which are generally more flexible, are not allowed for boom hoist reeving except for derricks.
Oh,
The boom
interesting.
hoist reeving needs that extra strength and stability.
Gotcha. So fiber core ropes are out.
Right.
Are there any other restrictions?
Yes, and this is where those rotation-resistant ropes we talked about come in.
Okay.
OSHA has a lot to say about their use in boom hoist reeving systems, especially when it comes to this thing called the operating design factor.
Now you've had me curious. What exactly is an operating design factor?
Think of it like this. You're lifting a 10 tons load, and your wire rope has a breaking strength of 50 tons.
Okay.
That gives you an operating design factor of 5, meaning the rope is 5 times stronger than the load it's lifting.
Right.
That extra strength is like your safety net.
Okay, so a higher design factor equals a bigger safety net. Makes sense. But why is it so important for this boom hoist reeving in particular?
Because boom hoist reeving is a critical function, it
Okay.
controls the angle of the boom, and any failure in the system
Uh-huh.
could be catastrophic.
Right.
OSHA wants to make sure that the entire system,
Yeah.
including the wire rope,
Uh-huh.
has that extra margin of safety.
This is starting to make a lot of sense.
Good.
We've covered a lot of ground so far, from selecting the rope to the ins and outs of boom hoist reeving. It's clear that there's a lot more to wire rope safety than meets the eye.
Absolutely. We've only just scratched the surface.
Well, this has been incredibly insightful. I'm already starting to think differently about wire rope. It's definitely not something to take lightly.
You got it. And remember, this information is not just for crane operators.
Oh, right.
Anyone working around cranes, anyone responsible for job site safety, needs to understand these principles.
I couldn't agree more. We'll dive even deeper into those rotation-resistant ropes and why they're so crucial for safe crane operations when we come back. Welcome back, everyone. Before the break, we were talking about how important these rotation-resistant wire ropes are,
Yeah.
especially for that boom hoist reeving.
Absolutely.
And you mentioned there are different types, type I, 2, and 3.
Right.
What sets them apart?
It really comes down to how they're constructed and how well they resist twisting.
Okay.
You know, think of a rope as a bunch of smaller wires called twisted together.
Uh-huh.
The way those wires are arranged determines how much that rope will rotate under a load.
So the more complex the twisting,
Right.
the better it resists that rotation.
Exactly. Type I ropes, they have the most complex construction, at least 15 outer strands arranged in multiple layers. It's almost like a tightly woven basket. This makes them the most resistant to rotation, and they're perfect for those heavy lifts where stability is super important.
So type I is for the, like, no spins on kind of jobs?
Yeah, you could say that.
You mentioned type 2 is a bit more flexible. Does
Right.
that mean it's not as strong?
Not necessarily weaker, just a bit simpler construction with at least 10 outer strands.
Okay.
Still very strong and resistant to rotation, but maybe not quite as much as Type I.
Mm-hmm.
It's a good choice when you need more flexibility without giving up too much stability.
Gotcha. And type 3.
Type 3 has the simplest construction, no more than 9 outer strands.
Okay.
It offers some resistance to rotation, but it's really best for jobs where spinning isn't a big concern.
So again, it's about choosing the right rope for the application.
Exactly, the right tool for the job.
But you also mentioned earlier this thing called the operating design factor and how it's especially important for boom hoist reeving.
Right.
Can you remind me what that is again?
Sure. The operating design factor tells you how much stronger the wire rope is compared to the load it's lifting.
I see.
Remember that safety factor of 5 we discussed earlier?
Yeah.
That's directly related to the operating design factor.
Okay, so a high operating design factor, more safety margin.
Right.
How does that specifically apply to boom hoist reeving?
Well, boom hoist reeving, that's a critical function.
Uh-huh.
And any failure in this system
Yeah.
could have really serious consequences.
Right.
So OSHA has specific requirements for operating design factors just to make sure everything is extra safe.
What kind of requirements are we talking about?
Well, for types 2 and 3 ropes,
Okay.
OSHA says you can't use them for duty cycle or repetitive lifts if their operating design factor is less than 5.
Hold on, can we break those down a little?
Sure.
What exactly are duty cycle and repetitive lifts?
Okay, duty cycle basically means the crown is working constantly, lifting and lowering loads all day.
Okay.
Like in a factory or something.
I see.
You know, like a marathon for the coin.
Yeah.
And repetitive lifts means doing the same kind of lift over and over.
Gotcha.
Like moving stacks of bricks.
Okay.
Both of these put a lot of stress on the wire rope.
Makes sense.
So OSHA wants to make sure you're using a rope that's tough enough.
So for those tougher jobs, you need a higher safety factor.
Exactly.
What about type I ropes? Do they have the same requirements?
Type I ropes, those are the heavy hitters, remember?
Yeah.
They need an operating design factor of at least 5, no matter what.
Okay.
Unless the manufacturer says otherwise, you know, in writing.
So 5 is like the gold standard for those type I ropes,
You could say that.
but you said there are exceptions for types 2 and 3.
Right.
When would you use those with a lower design factor?
You can use them for non-duty cycle and non-repetitive lifts, but there are strict conditions.
Like what?
Well, first, a qualified person has to inspect the rope before each lift.
Oh, okay.
They're checking for any damage, broken wires, kinks, corrosion.
Right.
If they find anything questionable, that rope is out.
Makes sense. Safety first.
Absolutely.
Yeah.
Second, the operator has to be really careful during the lift,
Yeah.
avoiding any sudden movements, jerks, anything that could strain the rope.
So smooth and steady operation.
Exactly. And finally, every lift had to be documented.
Oh, wow.
And that information needs to be considered during future inspections.
So it's like OYA is saying, okay, you can use a lower design factor rope, but you better be careful and keep a close eye on things.
Right. That's a good way to put it.
What really stands out to me is that there's so much focus on inspections.
Absolutely. Inspections are so important
Yeah.
for catching potential problems before they become major safety hazards.
Right.
A wire rope might look fine on the surface,
Uh-huh.
but a trained inspector knows what to look for, those subtle signs that could mean there's hidden damage.
So you can't just rely on the rope itself. You need that trained eye.
Exactly.
Okay, makes sense.
Let's shift gears a bit and talk about the actual installation of the wire rope.
Great point.
Because even if you choose the right rope and you inspect it carefully,
Yeah.
if it's not installed correctly, it can all be for nothing.
Right, we've talked about selecting the rope, inspecting it,
Right.
understanding those design factors.
Yeah.
But how do we actually make sure it's installed right on the crane?
Okay, OSHA's guidelines cover a lot here.
Mm-hmm.
But let's start with one of the most common methods, using wire rope clips with wedge sockets.
Okay.
These clips are essential for creating a secure connection.
Yeah.
But there are a few things to keep in mind.
Like what? It seems pretty straightforward.
Yeah.
You just clamp the clip on and you're good to go, right?
Well, not quite. First, those clips should only be attached to the dead end of the rope.
Okay.
That's the part that isn't under tension from the load.
Why is that so important? What could happen if you put a clip on the wrong part?
Imagine you're holding a heavy weight with a rope, and someone comes along and pinches the rope right above your hand.
Oh, yeah.
That pinch point would become a weak spot, right?
Makes sense.
Same principle applies to wire rope.
I see.
Putting clips on the live end, where the lurid is being applied,
Yeah.
can create a weak point that's more likely to fail.
Okay, so it's about making sure those clips are placed right to avoid any weak points in the rope.
That's it.
Gotcha.
And it's not just about where you put the clips, it's also about how you install them.
Okay.
You really need to follow the manufacturer's guidelines.
Yeah.
For socketing procedures, like to the letter.
Uh-huh.
They've designed the system to work a specific way,
Uh-huh.
and any deviation could compromise the strength of the connection.
So it's not one size fits all. Each rope and socket might have its own process.
Exactly. And speaking of details that matter,
Yeah.
there's another important step that often gets overlooked, and that's using seizings before you cut the rope.
Seizings, I'm not familiar with that.
A seizing is basically a tight binding that you put on the rope near where you're going to cut.
Okay.
Think of it like wrapping tape around a frayed electrical cord
I see. Okay.
to keep the wires from unraveling.
Gotcha. But why is that step necessary?
Because without a seizing, the wire rope strands can unravel when you cut it.
Oh, like a loose thread on a sweater.
Exactly, and that unraveling weakens the rope. You can be really dangerous.
Yeah, okay.
The seizing helps keep the rope's structure intact and prevents those loose strands from becoming a hazard.
So it's another one of those little details that can have a big impact on safety.
Absolutely. It's amazing how much goes into something as simple as a wire rope. All the thought and engineering.
It is, yeah.
And the more you understand about these details, the better you'll be at making decisions that keep you and everyone around you safe.
Well said. This deep dive into wire rope safety has been really eye-opening.
Good, I'm glad to hear it.
We've learned so much: picking the right rope, inspecting it for damage, understanding those operating design factors, even those intricacies of proper installation.
It's a lot to cover.
It is.
And believe it or not, there's still more to learn.
Can't wait. We'll be back after a quick break to wrap up this deep dive with some key takeaways and actionable insights and resources from Safety One Source that can help you put all this knowledge into practice. Welcome back to the deep dive. We've spent this whole episode talking about wire rope safety when it comes to crane operations.
It's a big topic.
It really is, and I have to say I've learned a ton. I never realized how much there was to know about something as, seemingly simple as a cable.
Yeah, it's more than meets the eye.
It really is. For me, the biggest takeaway is that wire rope safety is a team effort.
Definitely.
It starts with choosing the right rope for the job, then inspecting it, installing it right, making sure it's maintained.
Right, it all works together.
And it's not just the crane operator who needs to know this stuff. Everyone on the job site has a part to play in making sure every lift is safe.
Couldn't agree more.
Speaking of, making sure things look right,
Uh-huh.
I was really struck by how important those inspections are.
Yeah, super important.
A wire rope might look fine to someone who doesn't know what they're looking at.
Right.
But a trained inspector They know exactly what to look for.
Exactly, those little signs that could mean there's a hidden problem.
Yeah, like those subtle hints that something's not quite right.
You got it.
And inspections aren't just a one-time thing.
Nope.
Wire rope needs to be checked often, throughout its whole life.
Right, especially after anything that could have caused damage.
Yeah, like a sudden shock or if something's dropped on it.
Exactly.
And we talked about those operating design factors, how those safety margins get smaller as the rope gets older and wears down.
Yeah, wear and tear takes its toll.
Even if it looks okay on the outside, it might not be as strong as it was when it was new.
That's why those manufacturer recommendations are so important.
They really are.
They've done the testing. They know how long their ropes will last under different conditions.
Right, following their guidelines helps make sure you're not pushing a rope past its limits.
Exactly, using it safely.
And let's not forget about the installation.
Important part of the process.
If the rope's not installed right, it doesn't matter how good the rope is.
Right, all that other stuff doesn't matter if it's not installed correctly.
We talked about putting those wire rope clips in the right spot, using the right procedures, even those little seizings.
Yeah, the seizings.
To keep the rope from unraveling.
It's all about attention to detail, following those instructions.
So any advice for our listeners?
Definitely.
The crane operators, the pliering operators, the safety personnel, anyone who wants to make sure they're doing everything they can for a safe lift.
My biggest piece of advice, never stop learning.
Okay, yeah.
This industry is always changing. New technologies, new technique.
Makes sense.
Make it a habit to stay updated.
Good advice. And I'd also say, don't be afraid to ask questions.
Oh.
If you're not sure about something or if something just doesn't feel right.
Yeah, speak up.
Whether you're the operator, a rigger, or the signal person.
Doesn't matter. If it doesn't feel safe, say something.
Safety is everyone's responsibility.
It really is. And for anyone looking for more information on wire rope safety, I always recommend checking out Safety One Source.
Great resource.
They have a ton of info on their website, training materials, videos, even certification programs.
Sounds like a great place to go for anyone who wants to learn more and stay current on those industry standards.
It is. And remember, knowledge is power when it comes to safety.
Well said. We've covered so much in this deep dive.
We have.
And I hope everyone listening has a better understanding of just how important wire rope safety is.
Me sure.
And that they'll keep working to create that culture of safety on every job site.
Absolutely. Stay curious, stay informed, and stay safe.
Couldn't have said it better myself. That's a wrap on another deep dive. Until next time, keep exploring, keep learning, and keep those conversations going.